Hello friends and welcome to today's lecture. Today is the fifth lecture of the Big Data tutorials, and in today's lecture we are going to talk about the Hadoop distributed file system. So let's get started. In today's tutorial we are going to cover some of the challenges which we face with the traditional storage systems and why do we actually need a distributed storage system like HDFS. At the same time, we will also try to understand some of the terminologies of HDFS, and we'll try to have a look at an architecture diagram which will show how HDFS actually works. So let us get started. First of all, let's understand what are the challenges with the traditional file systems. So when we talk about the traditional file systems, first of all, they are not very cheap. For example, a normal 1 terabyte hard disk could cost you somewhere between $49 to even $100. Similarly, when we talk about speed, there is a certain limit to which these hard drives can work. The maximum speed achievable is around or somewhere around 300 megabits per second. And at the same time, when we talk about the reliability factor, since we have an individual hard drive, if it gets lost or if it gets corrupted, then your data is gone. So these are some of the very common challenges with traditional file systems, that they are not very cheap, they are not very fast, and they do not provide you with any reliability factors. So trying to fill all of these three gaps, HDFS try to basically create some sort of features which can fill up the gaps which were created by these traditional storage systems. For example, when we talk about the cost, as we said that for a traditional hard drive of 1 terabyte, it could cost you somewhere between $49 to $100. But when we talk about HDFS, first of all, there is no licensing and support fee. And when we talk about the speed, it can reach up to 1 terabyte per second of speed. So you can see from 300 megabytes per second to 1 terabyte per second. So the gap is huge. At the same time, as we have talked in the previous lecture as well, that HDFS tries to create multiple copies of the same data block across different nodes in the cluster, and that's how it achieves reliability. So even if one of the machine's hard disk goes down, still your data is safe because it is already replicated to multiple nodes. So this is, I think we have already seen this definition multiple times, so I will just quickly walk past through it. That when we talk about Hadoop distributed file system, it's a distributed system which is designed to run on very simple, vanilla, cheap commodity hardware. It provides you with high throughput access to an application data, and it's quite suitable when you're dealing with big data or application with large data sets. So talking about some of the characteristics of HDFS, it is fault tolerant, as we have already established this in the previous lectures. If you want to understand how it is fault tolerant, please watch my previous lectures where I've in detail with the diagrams explained how it is fault tolerant. The basic idea is that even if the data is lost on a single node, the data is still there in the cluster because it is already replicated. When we talk about the other characteristics, it's quite scalable because it can support from gigabytes to terabytes to even petabytes of data being stored on the HDFS clusters. So it's very scalable. It can go to really high data size limits. It's quite rack aware. It always keeps track of the state of the data nodes to remember which particular disk was stored on which rack, because when we talk about this whole solution, the whole HDFS setup is basically a bunch of computers, right? And those computers are mounted on racks in the data centers. So HDFS is aware about those racks. It also provides support for heterogeneous clusters, which means that it can store relational and non-relational data and logs data and different varieties of data. Other type of clusters are homogeneous clusters. For example, the RDBMS systems are generally homogeneous systems. They can either be SQL based or no SQL based, or they can be video storage or they can be JSON storage. But when we talk about HDFS, it's quite heterogeneous. It can store multiple forms of data. And we have already established that it is built for large data sets. Let's understand some of the terminologies of HDFS. So first of all, let's understand what is distribution. So as we said that HDFS is designed to support very large files, the way it does that or achieves that is basically it splits a very large file into small chunks, and those chunks are called as data blocks. Now these blocks basically contain some data which can be read or written, and HDFS stores each file as a block. So each of single file is divided into blocks, and then each block is basically a portion of the file which HDFS uses to read and write the data. By default, the block size is 128 megabytes, but this is the default value. And if you have really huge files and you have a lot of a very big cluster, then you can change this value depending upon your requirements as well. So that is about the distribution. The next terminology which you are going to come across quite often when we talk about HDFS is replication. And replication is basically the process of making a replica of data basically. So what I mean by that is that once you write the data, it is written at one place, and then it is also copied to multiple places. So at one node it will be written, and at the same time it will be copied to multiple nodes. We will understand this with the help of an architecture diagram in the coming slide. So the whole idea is basically the data blocks will get replicated, which will in turn provide us fault tolerance. And again, this is also configurable because this whole replication process is controlled by a value which is called replication factor. And replication factor is the value or is the number by which your data should get duplicated in the cluster. If you give a replication factor of 3, then there would be at least 3 copies of your data in the HDFS cluster. If you give the replication factor value as 5, then there would be at least 5 values of the same data in your HDFS cluster. And this is also configurable. So moving on, how does it actually store the data? Like I said, I will be explaining this with the help of an architecture diagram. So here you can see we have a data file, and we have split the data file into multiple 128 MB blocks. So you can see 1, 2, 3, 4, 5. So let's say this is a very sample or very hypothetical example of a data file. So we have split the data file into 5 blocks, and then we pick up one block. Let's say we pick the block number 2, and then we write the block 2 at least 3 machines in the HDFS cluster, which means that it is working on a replication factor of 3, which is the default value of replication factor when you set up HDFS. So it takes the block and it makes sure that it writes the block to at least 3 different data nodes in the whole HDFS cluster. And the same concept is applied to other blocks as well. If you take 1, it is written here, here, and here. If you take 3, it is again written at 3 different places. So every block of the data will be written at least 3 places. So now if this particular data node goes down, and if you still have to read block 2 of the data, you can still read it from this data node or this data node. Even if this data node also goes down, still you have at least one copy of it available. So you can, based on your requirements, you can configure this replication factor, and whatever value you provide, the data blocks will be replicated to the same number of nodes. So this is a very simple introduction and understanding of how the HDFS architecture works when we try to read and write the data. And that brings us to the end of today's lecture. We talked about the different challenges in the traditional systems. We talked about how HDFS works. We talked about its characteristics and terminologies, and we looked at an architecture diagram to build an understanding how the data is read and written. And at this point, I would like to stop this lecture. I just wanted to keep it simple and brief. I did not want to bore you with very long lectures. So we will meet in the next lecture. We will go into further details of this topic. Thanks for attending this lecture. And if you like this video, please like, share, and subscribe. Thank you.